So lesson 8.5, we're going to be continuing with our work on exponents and be looking at powers and products of quotients. And so our big idea is because of the relationship among multiplication, division, and powers distribute over powers and quotients. So you'll find that we've actually already touched on most of this. We kind of just looked ahead and prepped you for this without actually diving fully in. So today we're going to specifically look at raising a product to a power and a quotient to a power, and what does that look like? What are the special properties? So things we've already done, just kind of mixed in, and now we're going to look specifically at what all of that means. So there's two properties that hold true that allow us to do a lot of this simplification. First one being the power of a product property, and that one says that a times b raised to power n is the same as or equals to a to the n times b to the n. So it's distributing. Instead of multiplying a and b and then raising that number to a power, it's the same as taking a raised to that power and b raised to that power and then multiplying later. So let's actually make an example of this and see if it works. So what if we did 5 times 2 raised to the second? So that's a and b. That should equal, if we distributed this, 5 squared times 2 squared, according to this property. So let's work out both sides and see if this actually holds true. So on this side of the equation, you have to do parentheses first. So 5 times 2 is 10. And so it's going to be 10 squared, which we know is 100. And so if this property holds true, I need to get 100 on the other side. Well, 5 squared is 25. You do exponents first. And 2 squared is 4. And 25 times 4 is 100. And so this proves that, at least for these numbers, any non-zero numbers is actually what it is, that you can distribute this power when you have a product inside parentheses. So multiplying a times b and raising it to the power is the same as a to the power times b to the power. Now the quotient property is very similar. So if you have a quotient inside parentheses, so a divided by b raised to the n, instead of dividing and then raising it, you can actually bring that in to both of them. And so you have a to the n over b to the n, which again means that you could basically distribute this and raise these two numbers to the power and divide later. Now, when you're actually working with just straight up numbers, it often doesn't make a difference which way you would go about it. But as we try and simplify things with variables, it's very helpful to be able to move between the two so that you can kind of combine things and eliminate some things, factor some things out along the way. So let's prove that this one works. Let's take 1/4 raised to the second. That should equal 1 squared over 4 squared. So basically this comes in to both the numerator and denominator both get that exponent of 2. So 1 squared over 4 squared. And so we know that 1 squared is 1 and 4 squared is 16. Remember what this actually means, 1 divided by 4 raised to the second power. Now if I divide this, I'm going to get a decimal. But anything squared means times by itself. So this is 1/4 times 1/4, which does equal 1/16. So you can see that this is going to work. All right, so those are the powers, the power of product property and the power of a quotient property. So let's go ahead and run some of these. And again, these don't look like anything new. We've already kind of looked at this, but let's dive a little deeper. So when you have these parentheses, that exponent of 3 is not just on the x, it's to the 4 as well. And so if I was going to rewrite this according to this rule, a and b is 4 and x and n would be 3. So I can rewrite it as 4 raised to the third times x raised to the third. And if I'm going to simplify that, I'm going to get rid of 4 to the third. And that's 64. And x to the third just stays. I can't do anything with that. How about this one? Same idea. 5 is your a, x squared is your b, and this 5 out here, the exponent is your n. So I can split them up. 5 to the 5th. So basically you're taking this exponent and bringing it to both of them. So 5 to the 5th times x to the, now right here, this x had a 1. 3 times 1 gave you 3. But sometimes it just looks like, since there's nothing there, that the 3 attaches. Okay, it is being multiplied, so this is 5 times 2, and this is 10. So remember, when you raise a power to another power, you multiply those two exponents. So x to the 10th isn't going anywhere. 5 to the 5th, though, we can simplify that and get the actual number, and that's 3,125. X to the 10th. All right, and the last one, same idea. Now we have multiple variables going on here, but still this 4 is going to come to everything, so it's going to go to the y, and it's going to go to the x, and it's going to go to the 9. And again, it's not 9 times 4. This is a coefficient. It's 9 raised to the 4th. It's x squared raised to the 4th, but when you raise an exponent to another exponent, they get multiplied, so it's x to the 8th. And then same thing here, y to the 12th. And we're going to go ahead and raise 9 to the 4th now and get the actual number, and it's 65, 61, x to the 8th, y to the 12th. All right, so that's kind of some practice with some basic problems using the power of a product property. So example number 2, we're going to kind of just go through some basic examples of power of a quotient property. So 3/4 raised to the 5th, we can rewrite that as, according to this rule, we're starting off a and b are 3 and 4. So you can basically distribute that exponent to both of them. So 3 to the 5th over 4 to the 5th. And all we would do is actually expand and simplify those numbers. So 3 to the 5th is 243, and 4 to the 5th is 1,024. And so 3/4 to the 5th is that. And it should make sense because you'd be lining this up and doing 3/4 times 3/4 times 3/4 times 3/4 times 3/4 5 times, because it's to the 5th power. So an exponent tells you it's being multiplied 5 times. And so if you look across here, it's 3 times itself 5 times, that's 3 to the 5th, and 4 times itself 5 times, that's 4 to the 5th. So this should make some sense. Now, when you come over here with some variables, this is the whole reason that we're kind of exploring these properties, is so we can simplify some of these algebraic problems. So everything is going to get this 3, all of it. So that includes the coefficient, that includes the variable on the top, that includes the variable on the bottom. So as we bring it here, that's 2 to the 3rd. And then we bring it here, and that's m to the 3rd. And then we're going to bring it to the bottom. You're going to have to multiply there, and that's n to the 6th. At that point, you'd simplify. 2 to the 3rd is 8. And none of the letters canceled. We don't have any negative exponents, so we don't have to move anything around. That's a good final answer. All right, so let's apply this property now with negative exponents. And again, you've already seen this to a certain degree, so this shouldn't be too bad. So first of all, this exponent only goes to whatever's inside the parentheses. So this 2 is just going to hang out front. We can go ahead and just leave it there. But this raised to the 4th is going to distribute to both of these. And remember that when you are raising a power to a power, you're multiplying. So negative 2 times 4, that's x to the negative 8. Y comes in, this is really a 1, and this is y to the 4th. Now we're not going to leave negative exponents. This is a good non-fractional answer. But if we want an answer with positive exponents, then we got to take that 8 and we got to move it. And so that's going to go to the bottom. You're going to leave the 2 and the y to the 4th up top because they have positive exponents. X to the negative 8th comes to the bottom to create a positive exponent, and you have simplified it. Now this is where things can get a little tricky, because now we're going to distribute a negative exponent, and it's going to go to the coefficient. The 2 is actually there on the inside. So the coefficient is going to get a negative exponent, and that's where most people start to mess up. So is the a, so is the b. So if we're just going to write it out as a non-fractional answer, it's 2 to the negative 3rd. It's a to the negative 6th multiply, and b to the negative 9th. Now most people get that far, and then what they do is they try and plug 2 to the negative 3rd in their calculator, or any of these negative exponents, and it gives them a decimal, and they want to just write this decimal and round it because it's usually a nasty decimal. Okay, we're not doing that. We know that a negative exponent sends it to the bottom. it's going to create a fraction, and we want to leave it as a fraction. We're not going to create some nasty decimal. So since all of these are negative, they're all going to the bottom. So it's going to be a 1 on top. It's 2 to the positive third. It's a to the positive 6. And it's b to the positive 9. This would be done, except we never want to leave it as 2 to the third. If we can actually expand it and simplify it, then that's what we're going to do. So everything's going to stay except 2 to the third. We know is 8. And now we're fully simplified. So I'd rather have 1/8 as my numbers along with the variables as opposed to some decimal that represents that. Okay, so when you get a whole number raised to a negative, don't plug it in your calculator. Look at the crazy decimal that it gives you and write that down as your answer. Take it and move it to the denominator so that the exponent becomes positive, and then you can expand it out to a usable number.